Next, we're going to learn how to graph from standard form. If you remember from your quadratic equations unit last year in Algebra 2, standard form is when you have ax squared plus bx plus c. So a, b, and c will be numbers in the equation. So in our equation, we have an a value of 1 because we're multiplying our x squared by 1. We have a b value of 6 because we're multiplying our x by 6. And we have a c value of 5. C is the constant. You're not multiplying it by any variable. So the first thing that you want to do when you're graphing a quadratic equation in any form is determine if the graph opens up or down. The way that you do that is by looking at what's called the lead coefficient. So in our case, the lead coefficient is our a value. It's whatever you're multiplying by the x squared, or what would be outside the parentheses if it's in vertex form. If it is positive, like ours is, our a value is 1, then your graph will open up. And if it's negative, then your graph will open down. For standard form, the next piece of information we need is the axis of symmetry. To find the axis of symmetry, we use this equation. You've got it over here in your right-hand column. Negative b, or opposite of b, over 2a. Remember, the axis of symmetry is the vertical line that the graph is reflected across. So we have the opposite of b, in our case negative 6, over 2 times a. Our a value, what we're multiplying by the x squared, is 1. Negative 6 divided by 2 is negative 3. So our axis of symmetry is x equals negative 3. That's the vertical line that our vertex will go through. So to finish finding the vertex, we take that x value that we just found and we substitute it back into the equation to solve for the y-coordinate of our vertex. So we have plus 6 times negative 3 plus 5. So the y-coordinate of our vertex, we have 9 minus 18 is negative 9, plus 5 is negative 4. So our vertex is negative 3, the x value that we substituted into the equation, negative 4, the y value that we got out. Next, we need our y-intercept. We need at least one more point on the graph in order to get our parabola, and the easiest point to find is the y-intercept. Remember, the y-intercept occurs when x is 0. So we simply replace all of our x's with 0 and solve for y. In this case, our y-intercept is 5. When you go to graph, it's helpful to have that as an ordered pair, 0 for x, and we solve to get 5 for y. And finally, we'll put everything all together on the graph. We'll use that vertex, most important point on the parabola. We'll use our y-intercept, and we'll use the axis of symmetry to get the parabola shape. I'm going to call each of these 2. So I'm going to graph my vertex first. My vertex was negative 3, negative 4. My y-intercept was 5, or 0, 5. And then we use our axis of symmetry. So that's a vertical line that goes through our vertex. And what we can do is we can flip the y-intercept across our axis of symmetry. So we'll get another point on our parabola over here at negative 6, 5. Once we've got 3 points, we can create our U-shape parabola graph. Next, we'll find the domain and range. Because it's a parabola or a quadratic function, the domain will be all real numbers. All quadratic functions have a domain of all real numbers. Our range, remember, is based on the y value of our vertex. Because our graph is opening up, our range will be greater than or equal to, and the y-coordinate of our vertex is negative 4. We're going to practice another one, finding all the important information, except for graphing it. So first of all, does our graph open up or down? In order to determine that, we look at our lead coefficient, what we're multiplying by the x squared. If it's positive, it opens up. If it's negative, it opens down. Next, we find the axis of symmetry by using the formula x equals the opposite of b over 2a. So in our equation, our b value is negative 4. The opposite of negative 4 is 4, over 2 times that circled a value, that lead coefficient of negative 2. So 4 divided by negative 4 is negative 1. The equation for our axis of symmetry is x equals negative 1. That also gives us the x coordinate of our vertex. So to finish finding our vertex, we substitute that value back into our equation. And solve for y. So we have negative 2 plus 4 is 2 plus 7 is 9. So our vertex is negative 1, 9. Finally, we're going to find the domain and range. It is a quadratic, so the domain is all real numbers. And our range depends on if the graph opens up or down. Ours opens down, so its y is less than or equal to the y coordinate of our vertex, which in this case was 9.